Hello and welcome to our last lesson for Module 14. It's also our last lesson for quadratics. I know some of you are probably celebrating that. It's been a while. We've been doing quadratics for a while here. So I can solve word problems involving finding the maximum or minimum values. All right, so the width of a basketball court is 44 feet less than the length. If the area of the court is 4,700 feet squared, what is the width of the court? So let's figure this out. We're going to have two variables here, the width and the length. We know the relationship between the width and the length, and we know the width is 44 feet less than the length. So we're going to subtract 44 from whatever the length is. So we're going to let the length be x, and the width is going to be x minus 44. Whatever the length is, subtract 44 from it. Well, let's draw a picture. The basketball court is in the shape of a rectangle. The length and the width multiply together to get the area. So area is length times width. So I know the area is 4,700, so I'm going to put that in for area. The length is x, and the width is x minus 44. If I distribute the x, I get x squared minus 44x, and you can see a quadratic developing. Subtract 4,700, and there it is. There's my quadratic. Could I find the factors? Maybe. I don't want to spend the time doing it, though, so I'm going to go straight to my quadratic formula. This is a pretty complicated one with some big numbers. Good idea to go to the quadratic formula. So let's go ahead and do that. So negative b. So, sorry, negative, and b is negative 44. So negative 44 plus or minus negative 44 squared minus 4 times 1. A is 1, and c is negative 4,700. All over 2 times 1. Now we start simplifying. So negative 44 is positive 44, plus or minus. That number ends up being a very big number, all divided by 2. Now, if you take the square root of that number, you will get 144. It's actually a good perfect square. 44 plus 144 is 188 divided by 2. And then 44 minus 144 is negative 100 divided by 2. 188 divided by 2 is 94 and negative 50. So my width, can it be two answers? Or sorry, x is my length. X is representing my length. Can my length be two different numbers? No. Can my length be negative? No, which means my length is 94 feet. Now, what about the width? That was the question. What is the width of the court? So the width is x minus 44, or 99 minus 44, which is 50. So the width is 50 feet. Okay, here's another more real-life example of quadratics. So this equation here, it's given to us already, models the daily revenue for a company that makes scientific calculators, where R is the revenue and P is the price per calculator. So 3 questions with this, and we're going to solve each one individually. What price would the company have to charge for each calculator to make $1,000 per day? Second question, is it possible for the company to make $4,000 per day? And the third one, what is the maximum amount that they can make per day? 3 different questions, 3 different problems completely. So we're going to focus on the first one. What price? So what p-value? All right, so we want to see if they to make $1,000 per day. Well, $1,000 is a revenue. I'm going to put that in for R. Now to solve this, I have to subtract the 1,000. There's my new quadratic. I'm going to use quadratic formula here. Start plugging some numbers in. So negative 150 plus or minus negative 150 squared minus 4 times negative 3 times 280 all over 2 times negative 3. So I get a pretty big number inside the radical. Take the square root of that, 25,860. I get 160.8. We'll go ahead and simplify this for you. So negative 150 plus 160.8 is 10.8 divided by negative 6, which is negative 1.80. And notice the dollar sign there. X, or P here, is representing a price for the calculator. And then negative 150 minus 160.8 is negative 310.8 divided by negative 6 is 5180. Okay, 2 answers again. Makes sense, right? Because remember, the discriminant is positive. You should be getting 2 answers. But one of them in this situation does not make sense. The negative 180 would not make sense. You're not going to charge a negative amount for a calculator. The company's going to would have to charge $51.80 for each calculator according to this equation to make $1,000 per day. Is it possible for the company to make $4,000 per day? Is it possible? This is a yes or no question. What do we do with the yes or no question? Hopefully you remember it's the determinant. So I'm going to put $4,000 in for R, subtract 4,000, and now I'm going to do the discriminant with that. Is it possible? Let's see. 150 squared minus 4 times negative 3 times negative 2720. You get negative 10,140. No. It's a negative number underneath the radical. Therefore, there is no way for them to make $4,000 per day according to this equation. Last question. What is the maximum amount that they can make per day? Maximum is a very important word here. Maximum should make you think of a vertex of a quadratic or a parabola. Now, I'm not asking you to graph it, but what I want you to see is that the maximum amount occurs at the vertex. How do we find the vertex? The axis of symmetry. How do we find the axis of symmetry? This equation. We don't need to worry about the quadratic formula here, just the axis of symmetry. So let's plug those numbers in. Negative 150 over 2 times negative 3. So 25, is that their maximum amount that they can make per day? No, that is the p-value. The p-value is how much they would charge for the calculator to get their maximum profit. To find out how much they're going to make, you're going to put 25 in for p. So negative 3 times 25 squared plus 150 times 25 plus 1280. 25, put that in your calculator, you should get $3,155 per day. So what is the maximum amount that they can make? Right there. That's what you see. All right. And that concludes our module 14. It also concludes everything with quadratics.